Okay, today's introductory lecture about the production engineering, and we'll talk about it, what kind of jobs a production engineer can do, and what is the expectation and mindsets of the production engineer. First of all, let's look at it, the production system. There's a basic terminology we use in the production system. Well, production system is a composite term, is a complete term which describes 5 different areas at the oil or gas field. Number one is the oil reservoir or gas reservoir, or in general, say you can say the reservoir. Okay, this is the second one is the wellbore. Third one is the production conduit, which is the tubing or completion diagrams. Fourth part, the production system carries, which is the wellhead, exhaust tree, flow lines, and so on. And fifth one is the treatment facilities. So when we talk about the production system, we talk about in general 5 major things. One of them is the reservoir, which you see here. Second one is the this production pipelines, the well drilled after drilled. Remember, we are here not talking about the drilling anymore. We are talking about the production system. So reservoir, this is your reservoir we are talking about here. Then we are talking about the wellbore. And when we talk about the wellbore, this is the wellbore we are talking about, which has lots of casings. Inside the casing, there's a tubing, which is the job of production engineer to do it. Then the third part we say is the wellhead, where we have wellhead and a Christmas tree. Wellhead is the component which is holding all those casings. Otherwise, casings are cemented also, but at the top they are held by this wellhead. So that's why it is called wellhead. Then above the wellhead, we put the Christmas tree, which has lots of walls and so on. So this is the third component we are talking about. The fourth one is the separator and all those surface facilities we are talking about here. We have separator, the gas is separate, water is separate, and oil is separate. All of them are separated here and so on. As a production engineer, remember, we are not dealing with the reservoir. This is not our job. Okay, this job of reservoir management is the job of reservoir engineers. We are not dealing with drilling engineering either. Drilling engineering is the job of drilling engineers. They complete the well, they drill the well, they'll give us. That's it. They put the wellhead and they go. That's it. After that, the production engineer jumps in and he manages all of these things. Now, okay. For now, understand this is the major production system diagram. If we do the test, midterm, final, you will see this diagram somewhere, somehow, as in an exam. So I may ask you, draw the production system diagram and describe the production system. The production system contains reservoir, wellbore, tubings, Christmas tree, flow line, and treatment facilities, and so on. Now, what is the job of production engineer? This is most important. Well, production technologies has too many jobs you can find out. If you go to oilcarriers.com or other oil and gas engineering jobs, you can find too many things. But let's talk about the one by one. What is the job of production engineer? Production monitoring and evaluation. Well, production monitoring and evaluation, let me write in the most important slide. Okay, production and evaluation. Now, as you know that we have the well, which has Christmas tree, something like this one, and this well is connected with this reservoir, and this goes inside the reservoir. This is a simple diagram of the Christmas tree and reservoir and the wellbore in between them. Now, production monitoring and evaluation. First job of the production engineer to monitor what fluid is coming here. Okay, they monitor what fluid is coming out of a wellbore. Okay, when I say fluid, you can describe this term into a more better way. You can say the production data. When we say production data, we say that what fluids are coming out. And as you know that, for example, we have oil, we have gas, and we have water. So how much oil? How much gas? Let's say 70% oil. Let's say 10% gas and 20% water. So one of the job of production engineer, sorry, yes, one of the job of the production engineer is just to monitor this data. So you will be basically uh, given a job at the field, oil and gas field. You will sit in front of the computer. You will be given two technicians. You will have 15 to 20 wells to, to look after what is coming out of well. Okay, how much water? Every 12 hours, they make a report. Every 12 hours, they make a report of production oil. This much oil came out, this much gas came out, this much water came out. Okay, this is the first job. You monitor this production. And then this data, every 12 hours, you send to the head office. This is the least risk one job. I mean, it has no risk at all. This is the most comfortable job. Salaries are low, but very comfortable job. You go, you stay there, monitor the data, record the data, and send to the. This is the one job of the production engineer. As the other job starts the evaluation of this data. Okay, this evaluation is done in the head office. Okay, this evaluation is because production engineer at site, he send all this data to the head office, and at the head office, they evaluate this data. For example, okay, water production is increasing than last year. Okay, it's a problem. We have to figure it out why the production of water is increasing. Okay, then production is declining. For example, oil is 70%, maybe after 1 year, the production is maybe 50%. Oil maybe goes to 50%. So now it declined from the 70% to 50%. Why? This is the evaluation. Evaluation means why, what, how, all those questions. How, why, what, how can this be possible? Why this happens? So these questions, these words actually represents the evaluation part. Wherever you apply these words, why this is happening, how this is happening, when this happen, why this happened, who did this, what is the reason? So these kind of questions goes into the evaluation. So oil 70% decline to 50%, we have to evaluate. We must evaluate why this happened. And definitely we share this evaluation with the reservoir team also, that production has declined. There could be this reason. So one of the job, as we discussed, is monitoring and evaluation. You can be at site. They ask you to, in Kurdistan, mostly they hire Kurdish people, local peoples to do this job. They just monitor the data. And those who have masters and PhDs from US or those places, they evaluate the data, they make the decisions, and they get sent back to the production manager at the site to go and apply that. For example, increase the job, increase the production, decrease the production. The new team is coming from the head office to do this job, to do that job. So they just follow what they don't use their brain a lot. But those who are sitting in head office, they use their brain, their science, technology, research. They evaluate a lot of information, they prepare, they make decisions, and they hand out those decisions to the production manager at site. So by what we have discussed now, it means that we have production engineer at site, and we have production engineer at office. Production engineer, okay, production engineer at site monitors, production engineer at office evaluates. This is the first job that we do. Now let's go back to the second one, what we do. Okay, the asset management planning. Okay, the second, let me actually copy all of them and put in the whiteboard here. Okay, the second one is asset planning, management planning. Now, for example, in this well, we have one well. Okay, now a question can come. Now we have 5 wells. let's say we have 1, 2, 3, 4, 5, 6. We have 6 wells now. Okay, now 6 wells. The question can come here: how much production we can get next 20 years? How much you are expecting? This is a production engineer must answer to the company, because how much production what we are talking about is oil. Okay, how much oil we can produce in next 20 years? This gives the projection to the company managers to decide to apply for bank loan, to buy their luxuries, whatever they want, pay back their loans to the companies, governments, and so on. This is the asset management. Okay, the second part of asset management is how many more wells we are going to drill. How many wells we need for this reservoir? We 100 wells, 200 wells, 5 wells, 10 wells, 15 wells. How many wells we need? So this term comes in the asset management, that we have to manage our asset, tell us how much software, how much production we can get. And the software that you can use for this purpose is the GAP, which we have already got this software. We will have it on campus in the next, I'm expecting it soon. So let's see. I'm just waiting for the president's signature on that. But we are almost done with the process for this asset management training. Then sometimes, let's look now at the third: workover design and execution. Workover means, for example, now this well, because of the corrosion, this well here, because of the corrosion, this well here maybe is damaged here. Maybe there's a problem here, it is damaged. Okay, and workover means your well was already there, but then you have to fix it again. For example, you have to work on it again, like you do workover for sometime your homes. Okay, you do some reconstruction, do some repainting. So you have to remanage your wells again. There are a lot of problems can happen in the well. We will talk about it. What kind of problems, workover jobs can happen and needed for a production engineer to manage. This is the third thing. Now, based on this, how much production we get per day, for example. Now, let's talk about at the surface. Now, at the surface, we have 1, 2, 3, 4, 5, 6, 7. 7 wells we have here. Now, per day production is how much? Let's say you are producing 100,000 barrels per day. Yes, any question? Okay, maybe you are producing 100,000 barrels, 100K barrels per day, or maybe you are producing 200 barrel per day. Depends. First, you have to figure out how much oil you are going to produce per day. This is the job of the production engineer, and that can be obtained, settled down in the software called GAP. We will learn about it in this subject. Okay. Then the second thing is you have to design the facilities here. For example, now you have 100K barrel per day you are producing, then what to do with that? If you don't have the facilities to store them, then where you will put this oil? Or what you will do with that? Because for that you need a certain surface facilities. You need to design surface facilities that can handle 100K barrels per day of oil. Okay, but the problem is that this 100K is not going to stay there forever. Let's say it was 1 year. After that, it may decline. Decline, why? Because maybe water production is increasing. Because as I said, reservoir is always alive, dynamic, situation is changing all the time. We don't know what will happen after 1 year. So situation in production system is very uncertain. We don't know. So based on, for example, so what if this 100K turns out to be 30K per day, which happens with Jinel here in Kurdistan. If you go back, look at the Jinel news on google.com news, write Jinel water production. What happened? First, they estimated a lot of production. Then suddenly water production started. Then all their estimation, everything went wrong. And they had to downsize their shares, market, so many things, so many problems they faced. What happens later on that so much water production has started? So there's a lot of uncertainty exists in the surface facility design, which production engineer has to handle very smartly, that what kind of surface facilities is going to design. For example, in surface facility, the major thing is design the separators. What size of separators you need? Maybe you design the separator which can handle, let's say 100,000 barrels, but later on your company says, no, go drill more wells. Let's say you drill 10 more wells. Now 7 to 17 become, production become, let's say from 100 to 200,000. So maybe then you have to change those separators, maybe increase the size or maybe put some more separators. So this is the addition in with those. Then the another question comes, okay, water production increase after 1 or 2 years. Then what are you going to do with water? You cannot leave it in open air. You have to put it back, or you have to manage that water somehow. We call it water handling procedures. As a production engineer, you have to do that. So this is also you need to do. Okay. Then this is the surface facility design, production equipment design. You have to do that. Then the another part which is written here is cost estimating and budgeting. You have to do the budgeting. For example, how many wells you are going to drill or produce, how much will be the cost. Who will do that? The head of the production engineering department head. He will estimate all the cost. He will have a millions of dollars of budget in his account, freely he can use. Every company, they have their production managers, and these production engineers, their funds in their bank accounts by the oil companies, which they can use direct in millions of dollars, they can use with one signature. And under them, there's a lot of teams that are doing the cost estimating, budgeting, and usually he has 15 years of experience, definitely a Western nationality, and a very good salaries. These because they are the managers of all the production team, and they have a lot of responsibility, as well as they have a lot of perks and privileges those people have. So this is the roles and responsibilities, and we'll talk about the what are the jobs as a production engineer do. I will show you in the next slide. And after that, definitely you have to work with reservoir engineers, with oil companies and regulatory authorities, and so on. Any question? Okay, let's go ahead. And as I said, production engineering, the reservoir, which is the porous medium, we don't deal with reservoir, but we deal with artificial structures in production engineering, which includes the well, bottom hole, wellhead assemblies, surface gathering, separation. So as a production engineer, we handle the second part efficiently. Okay, now let's look at it. What oil company is expecting from us? What oil company wants from us to produce as much as possible. Means as much oil you produce, you make money. Oil is time is money, and production rates are money. So what oil company want from us is to produce highest possible rates. And secondly, they want to produce it for the longest time. For example, if you look at the field of Kirkuk, it is producing more than 50 years by now. If you look at the Rumaila in Basra, it's producing more than 50 years by now. If you look at the Saudi Aramco's production, which is near the in Dammam area, they are producing more than 50 years by now. And this is what they want. And definitely they are looking for minimum downtime, means they don't want to do the shutdown activity. They don't want to shut the wells. Even if the well shut 3 a.m. in morning, you have to go start it. Make sure that well do not shut off by any means. Even somebody is smoking cigarette at some distance, the smoke detector will shut the well. So you always have to monitor the production, that no production should shut in because of any smoke, cigarette or anything. And be very careful when you work, because your job is to ensure that all wells are working. You monitor the production data, you send it to the office. That's it. So as an oil company, they want maximum production, more life of the reservoirs, and minimum downtime. Let's look at the oil company, where exactly they are making the profit. In the exploration and drilling phase, okay, they are spending money. But in the operating phase, okay, they don't have a lot of investment. But after this phase, this is the phase there where they make money, a lot of money here in this phase, but in the operating phase. But then after that, when the field gets mature, pressure declines, they have to go for artificial lift methods, and then they have to spend money on it. But this phase is the most profitable one. If you look at this one, and their money starts in the operating phase and then ends up in the first two phase, they are not making any money. They are just investing. Usually, most of them are bank loans and so on. So many banks are involved. The personal investments are involved. So it's a different thing. But the revenue start in the operating phase, and so on. You as a production engineer, what they expect from you, what they want that you minimize the capital cost means do not put the separator more than needed. It means you have to design everything so perfectly. Minimize production cost means you make sure that you are producing efficiently. There's no water production, and you have to minimize the production cost means whatever stimulation jobs you are doing, you are allowing. So make sure that you spend the minimum and get the maximum. This is the business one. Minimize treatment cost, use the modern technologies, use your smart techniques, and try to minimize the cost to and minimize workover cost later on. If you are doing any workover job, minimize those costs. So what they want you to spend minimum. Okay, every business want that. If you are a businessman, what you will do, you will try to reduce your minimum cost, the operating cost. Okay, now I want to ask you two terms that are important in oil and gas or in any other business also. Those terms are, let me, and maybe you will see them in any interview also later on. OPEX and CAPEX. Can anyone tell me what are those? What is the OPEX and CAPEX? Okay. OPEX I can write for you, operating expenditures. CAPEX I can write for you, capital expenditures. Can anyone give me example in their daily life of operating and capital expenditures? Okay, let's take an example of when you buy a mobile phone. What is it? Is it operating or capital expenditure?
Capital.
It's a capital expenditure. So when you buy the phone, when you buy the smartphone, it is your capital expenditure. Okay, and when you load the credit into it, let's say 100,000 dinars. What is it? Now this is the operating cost. Okay, this is the, we call it, this is the operating cost. So the capital cost in expenditure, when you spend just to make something, buy some equipment or something, and then in order to run that equipment, you need expenses. For example, you have to hire engineers, you need to have electricity, you need to have food. So these are your operating expenditures. And capital expenditures are the one which you invest in initially in order to build that facility, design, plant, or whatever you're doing, or let's say mobile phone. But just when to operate, of course, mobile phone, you don't only need the credit, but you need the electricity also for that operating cost. So that is the part of operating cost at the same time. Now time is a operating expenditure is not is another debate. Okay, let's go ahead and look at where the production engineers are involved. The time scale involved. When we are talking from the start till the end, where the production engineers are basically involved. Well, when you start drilling the wells, they are there to design the casing and cementing, or casing and tubing jobs. So they design the casing job there. They tell you what kind of casing you need to use. Okay, drilling fluid selection is not their job. This is incorrect here. Maybe drilling fluid is not their job. Okay. Then the completion design, what kind of tubing size, 2-inch, 3-inch, 4-inch, 5-inch, whatever idea of tubing size you are going to use, what kind of quality you are going to. This is a pure job of production engineer of this one. Then, as I said, monitoring, completion, any workover, recompletion, recommendation, improve production system. Maybe you are changing the Christmas tree. Maybe you are putting some new technologies. And when you identify, when you see that 95% is producing water, it is useless to continue with that well. So your input as a production engineer, your input starts from the casing design, ends up with the end of the well when you abandon it, close it permanently. That time the production engineers is going on. Right now, for example, there's a recession, for example, an economic crisis. Drilling is stopped. Drilling is stopped. Production is not. Production has to continue. So production engineers' jobs are always there, whether there's whatever is the situation, and so on. Now, as a production engineer, what they do, what are their main jobs? Production engineer, and now we are talking about in technical terms, they talk about the well productivity, how much our well can produce, what is the capacity of a well to produce. They talk about the tubing design, how much size of pipes we should use, how we can stimulate, frac, or acidize our well, what kind of problems we can do, what are the artificial lift methods we are going to use, and how we do the surface. I will show you one of the examples. Now, in technical terms, there are 7 major fields that production engineer deals with: well performance, production enhancement, production problems, well monitoring, stimulation, surface, and so on. So let me show you some of the examples I have here. Oh, I didn't download them. Let's look at this one first of all. Your input is required here as a production engineer. The instructions come from the office that what kind of casings and intermediate casing you are going to use.
Sir, we cannot hear anything.
I think it has no voice.
Okay, thank you.
There is the volume. Now, this production casing is also the job of the production engineer because the oil will flow from this tubing. So what size of tubing you are going to use? This is the production engineer's job to design and discuss that production tubing. This is called the perforation, when you do the blast in the casing to make a communication between the reservoir and the casings. This is called the perforations. This also job is the production engineer's job, this perforation job, and we will discuss in one of the lecture ahead. These are the liners, slotted liners, which already has holes, and this is done in the reservoir area so that the reservoir do not get damaged and so on. And this is all production engineering.
Doctor, can I ask a question?
Yes.
Doctor, why instead of cement we don't use, for example, iron pipeline or plastic pipeline?
Plastic pipeline, we are dealing for the life of the well, let's say 50 years. Can the plastic handle 50 years? Okay, this is one question. Second question, what if there are high pressure zones behind the form? Can plastic handle that 50 high pressure zones? What if the pressure buildup blowout happens and these plastic pipes or things would not work? In fact, even if you go on the well side, they still have annular pressure. Even during the cement ruptures and there is pressure showing on in the annular space. So there are high pressures we are dealing with. We have to be sure that they are safe. So that's why we cement them properly.
Yes, sir.
I show you more. This is the fracturing job.
Hydraulic fracturing, more commonly known as fracking, is a process which allows natural gas to be extracted. Fracking has proven itself to be helpful in alleviating some dependence on the importation of foreign fuels and is a stepping stone toward new technologies and energy independence for the United States. Energy crisis faced surrounding the boreholes, such as protective steel casing, as well as additional cement casing at groundwater levels. To help visualize the extreme depths at which extraction occurs, imagine you are standing on the observation deck of the Sears Tower, now known as the Willis Tower in Chicago, Illinois, and you are looking down to the streets below. Now imagine 5 of the Willis Towers stacked on top of each other and looking downward from that distance. 5 Willis Towers stacked vertically are the equivalent of 7,700 feet, the approximate depth at which extraction occurs. One of the main concerns voiced by those opposing fracking is the potential to contaminate the underground water supply. Preservation of groundwater quality is the first priority in the fracking process, and this is addressed by placing additional steel and cement casings around the borehole to prevent leaks in the aquifer. As the borehole is drilled into the ground, it passes through many different layers of earth and several thousand feet of solid rock layers. These rock layers, such as granite for example, are extremely dense and therefore not affected during the fracking process. The density of those layers acts as a natural barrier between the shale layer where the extraction occurs and the groundwater level, and thereby will prevent any natural gas or chemicals from seeping into the groundwater supply.
They are trying to justify
Once
their.
the borehole has drilled down to the shale layer, perforating tools are then guided down the borehole carrying conductors. Once these tools are in place, the conductors emit a shock wave into the shale layer.
This is called the perforation. These shock waves. They
This
fracture
shock
them.
wave causes slight underground fractures in the shale layer. These fractures are also known as fissures. Once the fissures are created, the perforating tools are removed and brought to the surface. Water and sand are then blended with additives in preparation for insertion into the borehole. This mixture is made up of over 99% water and sand and less than 1% other additives. The water and sand mixture, or proppant, is injected into the borehole and travels down the depth of the borehole into the shale layer. The pressure caused by the water mixture allows the fissures to expand. Most of the water mixture is extracted and stored in a storage reservoir. However, a small amount of proppant is left behind, which consists mainly of sand. These small particles help the fissures to remain open. The open fissures make it easier for the natural gas to be extracted and flow towards the surface. The natural gas is collected in reservoirs, then pumped into container trucks and hauled away from the fracking drill site. The water and sand mixture is combined with a very small portion of chemical additives. These other additives make up less than 1% of the mixture. These additives can be found in products we use every day, such as laundry detergents and soaps, household plastics, deodorant, disinfectants, cosmetics, acrylic fibers, and food additives. Fracking provides a valuable energy source for the United States. Natural gas is a clean fossil fuel. Using natural gas as an energy source in lieu of other energy sources, such as coal for example, will reduce carbon dioxide emissions by 17% and thus lead the United States towards a carbon-light environment. Moreover, the abundance of natural gas on U.S. soil will not only support America's energy needs for a longer period of time than other fossil fuels, it will also create jobs, stimulate the economy, the environment next 9 years, which leads to a heavy reliance of foreign fuel imports. However, fracking will produce enough natural gas to sustain the energy needs of Americans for the next 100 years, bridging the gap and providing a sustainable. This video of the month was recorded with an Optis HD E-line camera run for an operator in Southeast Asia to provide critical diagnosis required for workover planning. The inspected well, previously a geothermal producer, was being injected with fresh water, and blockages had been registered during operations preceding the camera run. On the first frame, the down view camera is stationary inside the 13 and 3/8 production casing. The clarity of the video is remarkable.
Look at the around. It's not clean. There's a lot of material which is accumulated around the wellbore, which has reduced the diameter of the pipeline. Secondly, there is some leakage. That's why they are running the camera downhole to check where is the leakage, and then they have to fix that pipe.
For a larger diameter completion, there is significant scale buildup, and debris can also be seen flowing into the well at this point. On the next frame, the camera is switched to side view mode and rotates to inspect the production casing wall in more detail. Scale on the low side has been scraped off by previous equipment deployments. The down view camera then advances to the top of the 9 5/8 liner, where scale buildup, corrosion, and impact damage can be clearly identified.
Erosion.
As the camera is pulled up for a better view, the frame suddenly rotates as the wireline torque is released. At 1,703 meters, debris flow has reached landslide volume and scale deposits are heavy. The tool finally comes to a full stop at more than 200 meters above the anticipated hold-up depth, with the debris piled up causing a total blockage. As a direct result of Optis HD E-line video diagnosis, a scale cleanup operation was included in the workover program. Fortunately,
so they have to clean up this one, otherwise their well will not flow.
For the operator, a casing rupture was never the problem.
Cased holes may be perforated in several ways.
This perforation is the job of production
Conventional
engineer.
casing guns run into the well on electric wireline through wireline pressure control equipment. Using through tubing guns run into the well after the tubing has been installed. Or using tubing conveyed perforating guns run on the bottom of the tubing string and detonated using mechanical, electrical, or pressure-activated firing mechanisms. Also, the delivery system for placing the shaped charges at the proper location via wireline may be categorized as one of 3 possible types. Retrievable, consisting of a cylindrical hollow steel charge carrier, which is retrieved after firing and may then be discarded, as in the case of scallop guns, or reused several times, as in the case of port plug guns. Semi-expendable, in which case the perforating charges are conveyed into the well on a retrievable metal or wire carrier. Or fully expendable, where the charges and carrier linkage disintegrate on detonation, and only the wireline is retrieved.
Generally speaking, the larger diameter casing guns run via wireline will carry larger charges and thus give larger perforation diameters and greater penetration depths than the smaller through tubing guns.
Through tubing perforating, however, is a more practical method for underbalanced perforating than using conventional casing guns, and underbalanced perforating can help maximize productivity.
Tubing conveyed perforating seems to provide a means to combine both the larger high-performance guns with the flexible pressure conditions.
Okay. we are just introducing the concept. We will talk about them in each of the chapters. Our next courses will talk about them. Now I will show you one of the software that we use. Is Olga and Python. Schlumberger software is very nice software. How they look at the pipeline.
Predicting the complex behavior of slugs is critical for the safe and continuous handling of fluids. More than 30 years of ongoing field and lab research have helped refine the Pipesym and Olga simulators, so they can provide the most accurate prediction of steady state and dynamic multiphase flow across the widest range of production conditions. Effective strategies are required for everything, from restarting the system after an unplanned shutdown to designing an effective pigging operation. Models created with our simulators can be integrated into online operations, where real-time look-ahead and what-if modes can be used for a range of scenarios. With the most comprehensive suite of PVT, fluid flow, and heat transfer technologies, the Pipesym and Olga simulators offer a complete set of flow assurance tools for getting reservoir fluids to the surface in a safe and economical way.
And this is the artificial lift video. When the pressure of the reservoir declines, sometimes it is not able to flow. So then we install these pumping unit, jet pumps. And what they do, they use as a pump and they take the oil from the subsurface. They are very common. You might have seen them in the videos also. And as a production engineer, you may be artificial lift engineer, managing them from the office or from the field. Sometimes you have to go repair them, talk about them. Definitely Weatherford will train you for that. Weatherford is a very nice company for that, and they are doing this for a long time. This is another type of progress cavity pump. This is the most common gas lift. It's a very nice one and the most common one. We inject the gas, lower the density of the oil. Oil becomes lighter, easy to move ahead, and also it helps to increase the pressure, and they produce the wells like that. These are the artificially lift method, means they lift the oil artificially using these kind of techniques. Maybe we'll talk about the artificial lift in much details about their design procedures. This is the plunger pump. They have a plunger, it goes down like a bucket and brings the oil up in this bucket. It now takes the oil. Then it will go down again. It will lift the oil again. So they plunge it at me. There are 5, 6 different methods. 2 of them are very famous. One is the pump, the first one you saw, and the gas lift one. The rest of them are not really that good and not for the big reservoir, the big wells, oil wells. This is the hydraulic lift. Before I end this lecture, I would like to conclude it with the slide, this one. As I said, production technology has so many jobs. One of the job is to manage a production problem. And I just showed you a camera which has scaling, deposition, corrosion, and leaking of the production casing. This is one of the issue of production. Second one is stimulation. As I showed you the fracking videos, we have to do the fracturing process, this one. Monitoring, I talked about it. We have to diagnose why the production has declined, water production has increased, what is the reason. We have to monitor. And production enhancement using artificial lift method. I just showed you the pumps and plungers and gas lift and so on. Well completion is about the casing and tubing design. You have to talk about the casing and tubing about it, this one. And performance, which how much it can produce. So our next chapter will about the well performance one, and we'll have one project on the well performance where we'll use some softwares to do the well performance. This is the production engineer's job. So these are the main jobs that we will discuss. There is some minor description there given. We will talk about it in the next lecture, and today's lecture is gone, so time is finished, so we continue in the next one. Okay, so any question? Any questions so far?
No, thank you so much, sir.
Thank you, sir.
Okay, if you get any question, let me write to me, so I will see what. Sometimes.
Doctor?
Yes.
Sorry, I have a question. Does fracking only work for shale rock formation?
Yes. Yes.
Doctor,
Yes.
can you hear me?
Yeah, I can hear you.
I said, does fracking only work for oil rock, for shale rock formation?
No, it works for all. Sometimes the well is damaged, formation damage. If you remember the first workshop, it was about the formation damage. And if formation damage happen, we do this kind of fracturing. But it doesn't matter it is shale, carbonate, or sandstone or limestone. We can do, yeah, we can, as long as there's always a formation damage, and we always have to do for each of the well. Every well goes through this process of fracking. But in shale more, shale is like 50 times, 100 times. You know, shale depends on this one, but the other, for example, wells in Iraq, they do not depend on stimulation like fracking. But you still have to routinely do that. Okay. But for the shale formation, you do it 50 times, 100 times in a year, because there's already no permeability. So you create artificial permeability. But for reservoirs we have in Iraq or in Saudi or in other places, in Middle Eastern places, they have good permeability porosity, but there is a formation damage. But the reason we are fracking the shale is not the formation damage, but shale itself has no permeability. It's not about because of the formation damage. But here in Middle East, we do the fracking in the normal reservoir because of the formation damage. You got?
Thank you, doctor. Yes, thank you.
Okay. Okay, so see you in the next class. Have a good day.
Thank you, sir.
Thank you.